Good afternoon. Welcome back to Embedded World. I'm Rich Nass, Embedded Computing Design. My guest at this point is Haydn Povey, the CEO, founder, is that what you are?
That's right.
SCI Semiconductor. How you doing, Haydn?
I'm good, thank you, Rich.
So I hear tell that you have the world's most secure microcontroller.
Yes, that's right. The most cyber-secure microcontroller in the world.
That's pretty big words. How do you back that up?
They really are. They really are. And I think we kind of have to go out and we have to be big about what we're doing. Because the world is just so broken at so many different levels. We see it every day in big companies around the world that we need to have a better cybersecurity solution. And the way in which we're bringing that through is with the new Cherry technology, capability hardware.
Would you explain Cherry very briefly?
So Cherry was a project which evolved out of DARPA over the last 15 years. And the big problem is around memory safety, buffer overflows, pointer manipulation, use after free memory. And Cherry has been specifically designed to remove all of those attack vectors. So we take out 70% of the critical vulnerabilities and exploits that we see across the marketplace. And beyond that, we can use Cherry to then do blast reduction on other flaws in software, taking out nearly the other 30% as well. So we see it, as a very strong technology for solving the most pernicious of issues.
So tell me the history of SCI. People may not be familiar with the company.
So I set up the company nearly 3 years ago. Previous to that, I was Chief Strategy Officer at IAR for 5 years, and before that at ARM for many years. And fundamentally, I had retired. It was lovely. I had 2 whole days of retirement. And then got asked to come down and meet with the UK government digital catapult, looking at how we could bring this new technology to marketplace. ARM had done a great demo chip, test chip called Morello, which had proven the technology really well, but there was a gap around how it was commercialized, and the governments across the US and the UK are really keen to drive the adoption. So I met with that team. I was at the loose end. I was bored after 2 days. So I set up the company and away we went.
Very good. Now there's a lot of big guys who are in the same space. Why would somebody put their eggs into your little basket?
Well, I think there's a number of reasons. First of all, myself and other co-founders, we ran the microcontroller group at ARM for many years. We know where the bodies are hidden. Around this technology, and while PSA and other technologies are fantastic, they don't really solve the core problem around memory safety. Devices are broken around software, not around cryptography, at least not until Q-Day. So we're there to bring through new technology, and at the moment we really have a unique offering in the marketplace. We have a very strong patent portfolio in partnership with the core, which is produced for us by Microsoft and put in the open source domain. Really the systems around that are strongly protected and enable us to build strong devices. Fundamentally, if you want Cherry technology today, please come and talk to us, and we're very happy to help with our first Iceni chip, and also with the roadmap.
That's what I was just going to ask. Where are you in the development process?
So we have first silicon back, and it's fully functional. We will have full samples at the end of the summer, and we have a good number of customers already consuming those samples, engineering samples, and early production. But we're very keen to work with operational technology companies and see our critical national infrastructure, defense, aerospace, automotive, telecoms, really people who care about security are already aware of the memory safe issue. And the question is, how do you solve that?
So finally, with any technology, there's always a trade-off. If you want to be super secure, you got to give up something else. What is the trade-off here?
That's a really good question, because actually it's an inverted problem. The nice thing about solving the memory safety problem at root in the ISA is that we collapse a lot of the need for other pieces of IP. So memory management units are no longer needed because you're doing the memory management as part of the ISA. So that actually reduces the performance overhead by up to an order of magnitude on a lot of systems. Because of that, we can reduce power, and we can also embrace AI and fearless code reuse. The fact that you don't know exactly what's in your code, it's not actually a problem because the hardware platform will protect you. So we're seeing cost of development reduced, we're seeing power reduced, and we're seeing performance increased because we're solving the problem at the right point.
Is there an ecosystem around this, or do I have to learn new tools?
Don't have to learn new tools, and you can take your existing C++ code. It's a very simple recompile, and you inherit all of the memory safety. So that's great. We are building out the LLVM compiler. We're on LLVM 22. We're typically dropping between 2 and 48 hours after the main release, so in lockstep really. And we have our RTOS already ported, which is a native Chariot RTOS. And we have worked with various partners to port things like the free RTOS network stack. So if you have your favorite network stack, your favorite IDE, they'll be able to work with our compilers, with our tools, and it's a very simple, pretty painless software transition.
Very good. Thank you, Haydn.
Thanks, Rich.
That was Haydn Povey. He's with SCI Semiconductor, and I'm Rich Nass with Embedded Computing Design.